morning children. In today's class, we are going to discuss empirical formula and molecular formula. In the last class from Unit 1, basic concepts of chemistry and chemical calculations, we discussed up to gram equivalent mass. Now we are going to see about empirical formula and molecular formula. Once we have known the various elements present in any compound, the next point of interest is to know how much of each element is present in the compound. Elemental analysis of a compound gives the mass percentage of atoms present in the compound. Using the mass percentage, we can determine the empirical formula of the compound. Empirical formula giving the proportions of the elements present in the compound but not the actual numbers or arrangement of atoms. So what is empirical formula? Empirical formula of a compound is the formula written with the simplest ratio of the number of different atoms present in one molecule of the compound as subscript to the atomic symbol. Yes, empirical formula of a compound is the formula written with the simplest ratio of the number of different atoms present in one molecule of the compound. For example, let us consider the molecular formula of acetic acid. Yes, the molecular formula of acetic acid is C2H4O2. The different atoms present in acetic acid are carbon, hydrogen and oxygen. Okay children, the ratio of carbon, hydrogen and oxygen is 1:2:1. Yes, the empirical formula of a compound is written with the simplest ratio of the number of different atoms. So, the ratio of carbon, hydrogen and oxygen is 1:2:1. And hence, the empirical formula is CH2O. Okay children, the empirical formula is CH2O. Okay, yes. Then next, we can see molecular formula. Molecular formula of the compound can be arrived at from the empirical formula using the molar mass of the compound. Now we can see the definition of molecular formula. Molecular formula of a compound is the formula written with the actual number of different atoms present in one molecule as a subscript to the atomic symbol. Yes, molecular formula of a compound is the formula written with the actual number of different atoms present in one molecule as a subscript to the atomic symbol. Yes, for example, the molecular formula of acetic acid is C2H4O2. Now we are going to see calculation of empirical formula of the compound. Example sum number 1. An acid found in tamarinds and analysis shows the following percentage composition. 32% carbon, 4% hydrogen and 64% oxygen. Find the empirical formula of the compound. Children, before we calculate the empirical formula of the compound, we have to find out the total percentage composition of the elements. The total percentage composition of the elements should be 100. If it is not 100 means the remaining is the percentage of oxygen because there is no direct method for the determination of percentage of oxygen. It is always determined by a method of difference. In this sum, the total percentage composition is 100. Okay children, now we can calculate empirical formula of the compound. To calculate the empirical formula of the compound, we have to prepare a table. Then it should be divided into 6. Okay, there is 6 columns. Yes, the table should be divided into 6 columns. Okay children, yes. In the first column, we should write, yes, the element. Okay, in the first column we should write the elements, and in the second column we should write the percentage of the elements. Okay, and in the third column we should write the atomic mass. Children, not molar mass, atomic mass. Okay, yes. And in the fourth column we should write the relative number of moles of the elements. Okay, and in the fifth column we should write the simplest ratio of the elements. Okay, yes. And in the sixth column we should write the simplest ratio in whole numbers. Okay, yes. So in the first column we should write the elements, second column percentage of the elements, third column atomic mass, fourth column is the relative number of moles, fifth column is the simplest ratio, sixth column is the simplest ratio in whole numbers. Suppose if the simplest ratio calculated in the fifth column is not in whole number, means yes, yes, we should write the simplest ratio in whole number. Okay, children, yes, there is the simplest ratio. If it is in fraction, means it should be converted to whole number and written in the last column. Understand, ma? Yes. In this sum, the elements are yes, carbon, hydrogen and oxygen. Okay, children. Yes. So first we can substitute the percentage of carbon. Yes, the percentage of carbon is 32. Okay. Then its atomic mass is 12. Okay, ma? Yes. Now we can calculate the relative number of moles of yes, carbon. Yes, here what is that? Percentage divided by its atomic mass. So here the percentage is 32. Children, 32 divided by 12. Okay, yes, which is equal to yes, 2.66. Okay, if you divide 32 by 12 means yes, the value will be 2.66. Okay, children, yes. Then next we can calculate the relative number of mole of hydrogen. Okay, yes, percentage of hydrogen is 4. Okay, ma'am, its atomic mass is 1. Okay, yes, therefore relative number of moles of hydrogen is equal to yes, here percentage is yes, 4. Its atomic mass is 1. So 4 by 1 is equal to 4. Okay, ma'am, yes. The next oxygen. Yes, the percentage of oxygen given in the sum is 64. Its atomic mass is 16. Then relative number of moles is equal to, yes, we know 64 divided by 16. Okay, which is equal to 4. Okay, ma. Therefore, the relative number of moles of carbon, hydrogen and oxygen are 2.66, 4 and 4. Okay, ma. Yes. Then next we have to calculate the simplest ratio. Okay, yes, how to calculate the simplest ratio means by dividing the relative number of moles by its lowest value. Yes, the simplest ratio is calculated, okay, by dividing the relative number of moles by its lowest value. Okay, ma. Yes, so here the relative number of moles of the elements are 2.66, then 4 and 4. Okay, children. So among these values, the lowest value is 2.66. So to get the simplest ratio, yes, we should divide all the relative number of moles by 2.66. Okay, ma. Yes. Now we can see for carbon. Yes, for carbon, the relative number of mole is 2.66. Okay, so 2.66 divided by 2.66 is equal to 1. Okay, yes. Then next we can see for hydrogen, the relative number of mole of hydrogen is 4. So 4 by 2.66 is equal to 1.5. Okay, ma. Yes. Then next for oxygen, yes, the relative number of mole of oxygen is 4. So 4 divided by 2.66 is equal to 1.5. Okay, ma. Yes. Here the simplest ratio of the elements are yes, 1 is to 1.5 is to 1.5. Okay, children. Here the values are in fraction. It is not in whole number. Okay. Yes. Since the simplest ratio are in 1.5. Okay. Yes, for hydrogen and for oxygen. Yes, the whole should be, that is the whole simplest ratio should be multiplied by a common number. Okay, yes, suppose if the simplest ratio is less than 1.5, that is 1.3, 1.4 means we can write it as 1. Similarly, if the simplest ratio, okay, is there is more than 1.5, there is 1.6, 1.7, like that means yes, we should write the next whole number. Yes, since the simplest ratio is in 1.5, okay, the whole, okay, simplest ratio should be multiplied by a common number. Understand, children? Yes, so here we are multiplying by 2. Okay, yes, therefore yes, 1 into 2, 2, okay, for carbon. Yes, then for hydrogen, yes, 1.5 into 2 is equal to 3. Okay, ma, yes, then for oxygen, 1.5 into 2 is equal to 3. Okay, children, yes, therefore the simplest ratio in whole number is, yes, 2:3:3. Okay, children, yes, therefore the empirical formula of the compound is, yes, C2H3O3. Yes, an important 3-mark question. Then next we are going to see the second example sum. An organic compound present in vinegar has 40% carbon, 6.6% hydrogen and 53.4% oxygen. Find the empirical formula of the compound. To calculate the empirical formula, we should prepare a table, isn't it? Yes, then the table should be divided into 6 columns. The first column, elements should be written, and in the second column, percentage of the elements should be written, and in the third column, atomic mass of the elements should be written, and in the fourth column, we should calculate the relative number of moles, and in the fifth column, we should calculate the simplest ratio. Then and in the sixth column, yes, in the fifth column we should write the simplest ratio, and in the sixth column we should write the simplest ratio in whole number. Okay, children, yes, in this sum the elements are carbon, hydrogen and oxygen. Here the total percentage composition is 100. Okay, ma, yes, so the elements are carbon, hydrogen and oxygen. Okay, yes, now we can calculate the relative number of mole of carbon. Okay, first, yes, carbon, the percentage of carbon is 40. Okay, yes, its atomic mass is 12. Okay, then the relative number of mole of carbon is, yes, percentage by atomic mass, that is 40 by 12. Yes, if you divide 40 by 12 means, yes, which is equal to 3.3. Okay, children, yes, then next we can calculate for hydrogen. The percentage of hydrogen is 6.6. Okay, ma, yes, then its atomic weight is 1. Okay, yes, then relative number of moles of hydrogen is, there is 6.6 divided by 1, which is equal to 6.6. Okay, children, yes, the next we can calculate for oxygen. The percentage of oxygen given in the sum is 53.4. Okay, yes, then its atomic mass is 16. Okay, then relative number of mole of oxygen is, yes, that is 53.4 divided by 16. Okay, ma, this is 53.4 divided by 16, which is equal to 3.3. Okay, children, yes, therefore the relative number of moles of carbon, hydrogen and oxygen are 3.3, 6.6 and 3.3. Okay, ma, yes, then next we can calculate simplest ratio of the elements. Yes, how to calculate simplest ratio? Yes, it should be calculated by dividing the relative number of moles by its lowest value. Okay, here the lowest value is, yes, 3.3, isn't it? Okay, yes, the lowest value is 3.3. Okay, ma, yes, so we should divide the relative number of moles, okay, yes, by 3.3. Understand, children? Yes, now we can calculate the simplest ratio of the elements. Yes, for carbon, 3.3 divided by 3.3, yes, which is equal to 1. Then for hydrogen, yes, 6.6 divided by 3.3, that is equal to 2. Okay, children. Then for oxygen, yes, 3.3 divided by 3.3, which is equal to 1. Okay, yes, therefore the simplest ratio of the elements are 1:2:1. Here the simplest ratio is in whole number. Okay, children, yes, so write as it is in the last column. Okay, yes, therefore the simplest ratio in whole number is, yes, 1:2:1. Okay children, yes, therefore the empirical formula of the compound is CH2O. Understand? Yes, it is also one of the important 3 mark sum. Next we are going to see calculation of molecular formula. The formula for the calculation of molecular formula is empirical formula into N. That is, molecular formula is equal to empirical formula into N, whereas N is equal to molar mass divided by calculated empirical formula mass. Okay children, now we can see one example sum. Two organic compounds, one present in vinegar, its molar mass is 60 gram per mole. Another one present in sour milk, its molar mass is 90 gram per mole. Have the following mass percentage composition. Carbon 40%, hydrogen 6.6%, oxygen 53.4%. Find their molecular formula. Yes, here the total percentage composition is 100. Okay ma, yes. For the same percentage composition, just only we calculated empirical formula, isn't it? Yes. So no need to see, no need to explain or no need to see the empirical formula calculation. Okay. Yes. The empirical formula of the compound is CH2O. Okay children, for this composition, percentage composition. Yes. Since both the compounds, okay, yes, have same percentage composition, their empirical formula are the same. Okay, here two compounds, one is present in vinegar, another one is present in sour milk, have the same mass percentage composition. Okay, since both the compounds have same mass, percentage composition, their empirical formula are the same. Okay ma, yes, the empirical formula of the compound is CH2O. Okay, so to calculate the molecular formula, we need, okay, N value. We know N is equal to molar mass divided by calculated empirical formula mass. Okay children, molar mass of the compound will be given in the sum itself, we know, isn't it? Yes. So now we are going to calculate, okay, yes, empirical formula mass. Okay, empirical formula is CH2O. Yes, CH2O, there is one carbon, so 1, okay, 1 into 12. You know how to calculate, that molar mass. Okay, molar mass is calculated, yes, by sum of the, okay, atomic masses of all the constituent elements. Okay children, yes, already we sum. Yes, so here the empirical formula is CH2O. Okay children, yes, so we should multiply the the number of atoms by its atomic mass, then we have to sum up the values. Okay, so here one carbon, so 1 into 12, plus then there are 2 hydrogen, so 2 into 1, then there are, there is one oxygen atom, so 1 into 16, atomic mass of oxygen is 16. Okay, so 1 into 12, 12, then 2 into 1, 2, then 1 into 16, 16. Okay, if you sum up means, yes, the empirical formula mass is 30 gram per mole. Okay ma, yes. Now we can calculate molecular formula of the compound present in vinegar. Okay, yes, what's the formula? Molecular formula is equal to empirical formula into N. Okay, here the understand? Yes, then we should calculate the N value. We need N value. N is equal to molar mass of the compound divided by calculated empirical formula mass. The molar mass of the compound present in vinegar is 60, isn't it? So 60 by 30. Okay, that is equal to 2. So N value is 2. Therefore molecular formula of the compound present in vinegar is, yes, here molecular formula equal to empirical formula into N value. Empirical formula is CH2O into 2. Okay, yes, so C into 2, 2, then 2 2s are 4. Okay, so H4, then 1 into 2, 2. Okay, therefore the molecular formula is C2H4O2. Okay, what is the name of the compound present in the vinegar means? Yes, acetic acid. Okay, C2H4O2 is the molecular formula of acetic acid. Okay children, the next we can calculate, yes, molecular formula of the compound present in sour milk. Okay, yes. So here formula, empirical formula into N. Okay, N equal to molar mass divided by empirical formula mass or calculated empirical formula mass. Okay, molar mass of the compound present in sour milk is 90. So 90 by 30 which is equal to 3. Okay, therefore yes, molecular formula is equal to yes, empirical formula CH2O, n value 3. Okay, therefore 1 into 3, 3. Okay, so C3, then 2 3s are 6, so H6, then 1 into 3, 3, this is O3. So therefore the molecular formula of the compound is C3H6O3. Okay, yes, the name of the compound present in sour milk is lactic acid. Okay, C3H6O3 is the molecular formula of lactic acid. Okay children, yes, one of the possible 5 marks. Now we are going to see table number 1.62. In this table, molecular formula of the compounds are calculated from their empirical formula. From this table, you will be asked 2 mark questions. Understand children? The different compounds given here are acetic acid, hydrogen peroxide. Yes, the different compounds are acetic acid. Okay, yes, then hydrogen peroxide. Yes, then lactic acid. Yes, then tartaric acid and benzene. Okay ma, yes. So from this table you will be asked 2 mark question, that is empirical formula and molar mass of the compounds will be given. You will be asked to calculate molecular formula. Okay ma, yes. First we can see for acetic acid. The empirical formula of acetic acid is CH2O. Okay children, its molar mass is 60. Okay, yes. Now we can see its molecular formula. Yes, we know molecular formula equal to empirical formula into N. Then N is equal to molar mass divided by empirical formula mass. Yes children, you have to calculate empirical formula mass. Okay ma, yes. Here the empirical formula mass of acetic acid is 30. Okay ma, therefore N is equal to molar mass 60 divided by empirical formula mass is 30. So 60 by 30 equal to 2, N value 2. Okay, yes. Therefore molecular formula of acetic acid is empirical formula CH2O into N value 2. Okay, therefore its molecular formula is C2H4O2. Okay children, yes. The next we can see for hydrogen peroxide. The empirical formula of hydrogen peroxide is HO. Okay, its molar mass is 34. Okay ma, yes. Its empirical formula mass, there is a calculated empirical formula mass is 17. Okay, now when we can calculate N value, N is equal to molar mass divided by empirical formula mass. Molar mass is 34, then empirical formula mass is yes 17. Okay children, 34 divided by 17. Okay, yes, that is equal to 2. So N value is 2. The next molecular formula equal to empirical formula, okay, HO into N value 2. Yes, which is equal to H2O2. Therefore the molecular formula of hydrogen peroxide is H2O2. Yes, the next we can see for lactic acid. Yes, the empirical formula of lactic acid is CH2O. Okay, its molar mass is 90. Okay ma, yes. The calculated empirical formula mass is 30. Oh, yes. The next we can calculate N value. N is equal to molar mass divided by empirical formula mass. There is 90 by 30. Children, this is 90 by 30. Okay ma, which is equal to 3. So N value is 3. Therefore the molecular formula of lactic acid is empirical formula CH2O into N value 3. Yes, which is equal to C3H6O3. Yes, so the molecular formula of lactic acid is C3H6O3. Okay, yes. The next we can see for tartaric acid. The empirical formula of tartaric acid is C2H3O3. Okay children, yes. The next its molar mass. Okay, the molar mass of the tartaric acid is 150. Okay ma, yes. Then next we can see the empirical formula mass. The calculated empirical formula mass of tartaric acid is 75. Okay, therefore N value, N is equal to yes 150 molar mass, okay, divided by calculated empirical formula mass, that is 75. So 150 by 75 is equal to 2. Okay children, so here N value is 2. Therefore the molecular formula of tartaric acid is yes, empirical formula C2H3O3 into N value 2. Therefore, molecular formula is C4H6O6. Okay, ma? Yes. Then next we can see for benzene. The empirical formula of benzene is CH. Okay. Its molar mass is 78. Okay, ma? Yes. Then empirical formula mass for carbon S12, hydrogen 1, so 12 plus 1, 13. Okay. Yes, empirical formula mass of benzene is 13. Okay. Yes. The next N value. N is equal to molar mass divided by empirical formula mass. Here molar mass is 78. Then empirical formula mass is 13. So 78 divided by 13, which is equal to 6. Okay, children. Yes. Therefore, molecular formula of benzene is empirical formula CH into N value 6. Okay. Yes. Which is equal to C6H6. Okay, children. Therefore, the molecular formula of benzene is C6H6. Yes, children. Each compound is a 2-mark question. Remember, empirical formula and molar mass will be given. You will be asked to calculate molecular formula. Okay, children. So, all of you study this table thoroughly.